The reason we're going to talk a little bit about scientific notation is because we also want to talk about a really big number today, and or at least maybe today or tomorrow, actually, which is called the mole. Okay, so we're going to talk about a mole as an amount of an element containing 6.02 times 10 to the 23 atoms, which we call Avogadro's number. And we're going to apply that concept to calculate quantities of substances made in chemical species. Okay. Now, this should hopefully be reviewed, but if it's not, I guess you really need to pay attention. Some numbers are really large, right? Okay. And we need to have a simpler way to write those. And in order to do that, we need to use scientific notation. Some numbers are incredibly small. So once again, we don't want to write a bunch of decimals 0.00000 really small. We want to use scientific notation to accurately represent those. So, you know, for example, the speed of light, all right, is 300 million meters per second. 300 million meters per second. So if I wanted to change that to a number that, you know, 300 million is a pretty big number. If I wanted to simplify that and make it into what we call scientific notation, we would say, well, that's 3.0 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8 meters per second. Okay? So instead of writing all those zeros down, we use something called scientific notation. Now, scientific notation has 3 parts to it, and you guys are going to have to add stuff onto here too, so please pay attention. This part is called the coefficient, okay, right there. So that is the coefficient, okay. That is the number in front of the time sign, of course, the coefficient. This would refer to the base here, and this would be, of course, now unfortunately mine didn't go to the, let's do this, 23 here. That would be, of course, the exponent or power. There is 2 rules for scientific notation, okay? 2 rules for scientific notation, and we need to know these, okay? Listen, I don't know where along the line, but we take some liberties with this, and it's not cool, okay? I'll tell you it's not cool. It frustrates me to no end. Scientific notation is 2 things. It is a number, and you want to copy this down, between 1 and 10, and I'll put in brackets here, it cannot be 10. So it could be 1, but it can never be 10. So it could be like 9.999999, sure, but it's not 10, okay? So it's between 1 and 10, not 10, okay? That's the first part, okay? A number between 1 and 10. The second part has to be a power of 10, okay? And that might not make sense to you right now, but when we do a few examples, I want you to pay attention to those 2 things, okay? Look, let me ask you this. If you look back up at this, by the way, is called Avogadro's number, 6.02 times 10 to the 23. You're going to get to know that number very, very well in the next few days. All right? Is this number here, is that a number between 1 and 10? Okay. That's what I need to see there. Okay? That's what I need to see. You might be saying, well, like, what are you talking about? Well, is this a number between 1 and 10? No, so I don't want to see that, okay? So it has to be a number between 1 and 10. That is scientific notation, okay? And the second part is a power, so this is your power of 10. It tells you how many zeros to add on after, or how many zeros to add on before, by the way, okay? So, or sorry, that is, actually that's not Avogadro's number, I don't know what that is. So, if I took, for example, this number here, which is Avogadro's number, 6.02 times 10 to the 23, okay? If I took that number there, 6.02 times 10 to the 23, if I actually wrote that out, here's why we use scientific notation, guys. We're going to use this number probably about 50 times in the next 2 or 3 days. Okay? A lot is my point. Okay? Are you going to write this number out, 6.02 times 10 to the 23, or are you going to write this out? Because this is what that means. 3, 6, 9, 12, 15, 18, 21. There you go. Okay? That's a huge number, right? That's why we have scientific notation. I don't know about you, but I'm not writing that out every time. Okay? Number one, it takes too long. And number two, that's a lot of zeros. Okay? So 6.02 times 10 to the 23 means if the decimal was here, we're going to move it 23 places to the right because it's a positive. Okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay? That's what it means basically. All right? That number is huge. We don't want to write that out all the time. It takes too long. Okay? So that's what we're going to talk about instead, scientific notation. All right? Now, these numbers didn't really show up very well, so if you wanted to do this on maybe the back side or whatever, just as a few examples, that's probably not a bad idea. I'll write them out again. If it says here, if the exponent is positive, the number is greater than 1. So we should, if the exponent is positive, we should be moving the decimal to the right. Yes? Make the numbers bigger. If the exponent's negative, we should be moving it to the left, making it smaller. And in case you're wondering, yes, you can use that as a dance move. Gauge. To the right, if it's positive, for you guys, it's different for me. Left, negative, yes? Smaller, okay? Maybe it'll help you get, you know, a date or something, I don't know, probably not. Probably wouldn't dance like that. I dance like this with thumbs. All right. Okay, so here we go. The first one here is 93, what is that? 93 million, I guess, yeah? Yeah, 93 million. So let's take a look here. Oops. Here, let me go back here for a second. Hey. You're welcome. 93 million. Okay. So here we go. 93 million. That's a zero there. Okay. So if I want to write this as scientific notation, listen, it has to be a number between 1 and 10. What's a number out of that that could be between 1 and 10? Yep. 9.3, yes? Let me ask you this. If I put the decimal here, is 0.93 between 1 and 10? 9.3? Yeah. So that's what we want to write. Okay? So I'd say, okay, 9.3 is a number between 1 and 10. Okay? And times that by 10. So we need a power of 10 now. So it's always times 10 to the something. Okay? Is this number bigger than 1? So it should be a positive exponent, yes? So pretend now for a second. Look, my decimal's right here, 9.3. 9.3. My decimal is here. I need to move it 1, 2, 3, 4, 5, 6, 7 places to the right. Yes? So I'm going to put a 7 there. Okay? That's all you need to do. Okay? And I don't know if that makes sense or not, but basically moving in the decimal 7 places. Right now, by the way, in this number here, guys, if you looked at 93 million again here, let me just do this. Okay? Where's the decimal in this number? Where is the decimal in this number, 93 million? Is it here at the front? Is it here in this number? No. Is it here? Right. So if I want the decimal there, right, but it's here right now according to that 9.3, I need to move it 1, 2, 3, 4, 5, 6, 7 places to the right. Right? Okay? Good? Okay. Questions? Let's look at another one here. What's the next one here? what is it, 0.40, 5114, okay. 0.0000514. I don't know, maybe there's a 0 there too. There isn't, but that's okay. Okay, good enough. So look, okay, let's cut this off right here for a second. Okay, so this one, right? Whether the 0 is there in the front or not, it really doesn't have anything to do with it, okay? But once again, if I want scientific notation, guys, the first number that I write down has to be between 1 and 10. What's a number between 1 and 10? When you look at that, what's a number between 1 and 10? Yep. 5.114, yes? And you might even say 5.1, yes, okay? But remember, the only numbers that I can really represent by that times 10 part, so look here, guys, this is times 10 to the 7. That was all these numbers here, yes, basically, and actually the one more, yeah? That's why I said 9.3, right? This one here, I'd probably have to use 5.114 because I need to use those numbers because I can't represent those with zeros, right? So I want to keep that. So 5.114. And once again, guys, you know, you look at the numbers that are not zeros and you say, hey, is 0.5114 a number between 1 and 10? No. Is 5.114? Yeah, write it down. Okay. Is 51.14 between 1? No. We don't want that. 511.4? No. Okay. So we need to make sure that first number is between 1 and 10. Okay. It drives me bonkers when people don't do that. Okay. And I don't know where that came about. So somewhere along the line, I get that a lot for some reason. I don't know why. Okay. Scientific notation between 1 and 10. And now a power of 10. So times 10. Now, is this number bigger than 1 or smaller than 1? Smaller. Smaller than 1, yes. No. Okay. Okay. Smaller than 1, yes? So we need a negative. In fact, you could even put that in right now if you really want to. Okay? So we're going to need a negative power. Okay? So look, this says 5.114. If the decimal was here in this number, how many places do I got to move it to get it back to where it is? 1, 2, 3, 4, 5, yeah? So that should be negative 5. Okay? Good? Okay. 5.114 times 10 to the negative 5. Okay? And our last example here is what? Well, it's a negative 33,452.8. Okay? Good. Negative 33,000. I forgot already. I have one of these sheets. I should just look here. Yeah, these numbers didn't turn out particularly good here, guys. So, like I said, copy these down. 452.8. Okay. Now, in this example here, okay, first things first, we have a negative number. No big deal. Okay. Look, if it's negative 33,000, it's still going to be negative, right? So, where in this whole mess here are we going to put the decimal to make it a number between 1 and 10? Where are we going to put the decimal? Yeah. Yeah. So we want here, yes, is a number between 1 and 10. And it's a number with lots of numbers here. That's fine. But we want the decimal here between the two threes, yeah? Negative 3.3, right? So we're going to actually go negative 3.3. We want it there. Is that number between 1 and 10? Okay. Now, these numbers here, once again, I can't just use zeros to replace them because they're actual numbers, right? So I'm actually going to have to write out the whole thing here. I'm going to have to say negative 3.34528. Okay? So I'm going to have to use the entire number. Is that a number between 1 and 10 still? Yeah, it's just a very precise number, isn't it? Okay, it's got lots of decimal places, no biggie, right? And I need a power of 10, of course. Now, is this number bigger or smaller than 1? It is Well, I guess, yeah, that's a kind of a tricky question, isn't it? Technically, well, it is smaller than 1, I guess, because it's negative, but it is, we're gonna have to move the decimal to the right, yes? Okay, so we need a positive exponent. So it's not, basically, how to explain? It's not between -1 and 1, if that makes sense. How's that for decimals? Do you agree, though? Look, if the decimal was here, right, 3.3, which way am I moving it to get back to that original number? To the right or to the left? To the right, yes? So if it was here, 3.34528, I'd have to move it 1, 2, 3, 4 places, yes? Okay, to get it back to where it was. So that's why I want to put a positive 4 there. Okay, so maybe that's a little tricky on that one there, but that's what we need to do for that one. Okay, is that good? Questions, anyone? Okay, one more real quick here. Let's see. If you, oh, by the way, if you want to, let's go the other way now. Let's change this number from scientific notation back into a real number, like an actual number. So what do I need to do? Am I moving the decimal left or right here in this case? Left or right? What do you think? To the left or right? To the right, yes, because it's a positive 6, yes? So I'm going to take this number here. Here's my decimal. And I need to move it 6 to the right. 1, 2, 3, 4. Now, I'm only at 4 here. 5, 6. What am I going to put in these two spots here? Zeros. Okay? So I'd say, okay, 1, 4, 9, 5, 8, 0, 0. Yes? And then if you really want to, you can go back and say, okay, look, that is what? 1,000 there kind of thing, right? And that would be a million there. So it's actually 495,800, yes? Kind of thing. Okay, good? Yes? Yep. Well, okay. So yeah, that's the other part. So ignore the negative for a second. We need the negative there. But the 3.3 part is still between the 1 and 10, right? So what I'm saying is that that part there still, yeah, good point. That still needs to be between 1 and 10, always. So whether it's a negative or a positive, we need to have that number between those two, 1 and 10, okay? All right, good, yes? Okay, so we're almost out of time here, guys. So here's what I'm gonna get you guys to do. You guys have questions 1 and 2 on here, okay? So that's converting back and forth question 1 and 2, okay? So let's do that for tomorrow, okay? Number 1, of course, you're going to put those into scientific notation. Gives you a little example there. And the second one is you're going to take that number and you're going to change it back into an actual number. So take that scientific notation, change it back into number. Make sure you have enough room there. If you don't, do it on a piece of paper, okay? Just do 1 and 2 for tomorrow, okay? Don't forget quiz tomorrow, balancing, reaction types, etc. Okay, so make sure.